A theme park conducts a study of families that visit the park. The fraction of such families of size m is 8 minus m by 28. For a family of size m that visits the park, the number of members of the family that ride the roller coaster follows a discrete uniform distribution on 1 through m. Calculate the probability that a family visiting the park has exactly 6 members, given that exactly 5 members ride the roller coaster. So, there are two things. One is the size of the family, and one is how many ride the roller coaster. So let m be the size of the family, and n be the number who ride the roller coaster. And we need probability that the family size is 6, given that 5 ride the roller coaster. So probability m equals 6 given n equals 5. Now, we're using the term discrete uniform distribution here. So that's for the members who ride the roller coaster. So for a discrete uniform distribution on 1 through m, the probability of each point is 1 over m. So for example, the toss of a or the roll of a die is a discrete uniform distribution. There it goes from 1 through 6, and probability of each number is 1 over 6. So in general, it's 1 through m, and the probability of each number is 1 over m. So this is different from the continuous uniform distribution, which is on the interval, whatever interval they give us. This is not on an interval. So normally if it's a continuous uniform distribution, we don't say the word continuous. Uniform distribution means continuous. But if they want a discrete one, they will mention it. Although, even if they had said that it's a uniform distribution on 1, 2, through m, so since you can see that it's a discrete set of points, so you can track that it's a discrete uniform distribution. So even if they hadn't said it, just by looking at the domain, if they had only said that it's uniform distribution and given this domain, then since this domain is a discrete set of points, so we know that it's discrete. Okay, so another thing to note is that we have to find the probability that the family has 6 members given that 5 rode the roller coaster. So now if we are given that 5 are riding the roller coaster. So that can only happen if the family had at least five members, and at least 5 in this scenario means 5, 6, or 7, because the maximum is 7. Families are 1 through 7. So if 5 are riding the roller coaster, then the family size must be either 5 or 6 or 7. Okay, and now the usual formula, probability m equals 6 given n equals 5 is what we need. So that'd be probability m equals 6 and n equals 5 divided by probability n equals 5. So the values of interest are tabulated below. So the families that we need to consider, remember m was the family size, so the ones we need to consider are 5, 6, and 7, because that's when the roller coaster members could be 5. And the formula that was given for the probability of the family being size m, that was 8 minus m by 28. So we tabulate these probabilities according to this formula and these m values. And then the probability n equals 5 will be 1 over m, because as we said, the probability of n equals any point will be 1 over m, because it's discrete uniform on 1 through m. So it doesn't matter whether n equals 5 or 1 or 3 or whatever, the probability of any n equals 1 over m. So based on m equals 5, it would be 1 over 5. For 6, it's 1 over 6. For 7, it's 1 over 7. And now the numerator that we needed was probability m equals 6 and n equals 5. So that's found from this row, 2 over 28 times 1 over 6. And probability n equals 5. Basically, you find all these three products and add them up. So, because n equals 5 can happen with m equals 5, or m equals 6, or m equals 7. So this, or this, or this. And then we divide and we get 0.31. So that we've done so many of these problems in the first half of the set. Most of them appeared like under 100. So that was 0.31 was choice E.